Okay? Graphically, what does absolute value mean? Louis, zip it. Zip it. Absolute value, what does it mean? One definition is take the square root of the square of something. That makes it positive. Okay? Or, just remember, absolute value means, there's the two lines, that means absolute value of x can't have negatives. It's got to be positive. How far away from the number line is minus, I don't know, 6? 6 units away. Okay? Okay, that's what it means. Recall the definition. Now they're saying, well, this is a definition. I'm going to argue, well, that's what happens if you got a graph of the absolute value of x. I wouldn't really call it a definition then. Okay? This thing, if the function, now here the function is just x. Okay? If it's some big honkin' strange function, that goes in here. Okay? If it's positive. That's what it says. If x is positive. If the function's positive, you just write the function. And you don't worry about absolute value because it's positive, right? You only have to worry about this if it's negative. If the function's less than 0, i.e. negative, then we have to make this thing positive. How do you make that positive? By putting a minus in front of it. That's it. Okay, minus minus is plus. Okay? So this is what the original function y is x looked like. That was the first thing we saw. If I take the absolute value, what happens with the negative stuff? I've used the word flip. Okay, I didn't use the actual big kid math terminology. Now we're going to talk about it. But you guys have already seen this too. What can you say happened to all these dots here? What's the wordage, the proper stuff? Anybody want to take a stab at that? I hear this. But nobody's willing to. Okay, that's fine. We'll see it in a sec. Okay, an absolute value transformation transforms the graph of this to the graph of that. I don't care what f of x is. It's some function. And you're going to get some pictures of stuff. Okay, who knows what the equation of it is? Graphically, it's a piece of cake. All you do is take the negative stuff and make it positive. Okay? So, there's a graph, an original graph. I'm going to take the absolute value of it. This graph on this picture is going to be x minus 1. Okay? We can plot this. Okay? Feel free, but let's do some higher level thinking. What does that thing look like? How does x minus 1 compare to x? Okay? Do you know what this looks like? I hope so, because I just showed you a picture of it about 6 seconds ago. Okay? So x minus 1, transformation-wise, is going to be a horizontal translation 1 unit to the right. Okay? And quickly, let's just think about that. If x is 1, 1 minus 1, what's y? 0. There it is. Okay? So that's what this graph looks like. Now I'm going to dot this stuff, right? Because that's f of x, which in this case, well, let's just get rid of that. That's the graph of x minus 1. Okay? Again, if you got to plot every point, fine, feel free. That's what it looks like. Hold that thought. Math room. Okay. Caitlin. Office requires your presence. All right. Absolute value. Graphically, what happens? Narrow. Huh? What? Absolute value. If I take the absolute value of this graph, what happens? The negatives get flipped up. Okay? This point isn't there anymore. It's up there. This one isn't there. It's here. And so on and so on and so on. Okay? Let's actually do that in blue. Okay? So I'm still have this. If it's positive, it doesn't change. But if it's negative, okay, all you do is, again, we're using this word, flip. What line did I flip these over? Okay, hold that thought. When f of x, the original graph, is greater than or equal to 0, I've said it 10 times, now let's write it down. When it's positive, that says the same thing, the graph of the absolute value is, how did this change between the red line and the blue line? What's a word that fits in this sentence? Identical to the graph of y equals f of x. Okay? In other words, it didn't change. It's identical. However, when it's less than 0, when the values were negative, what did we do? This graph is a, now let's use the big kid words. Reflection where? In the x-axis, or some publications will say over the x-axis. Same thing, okay? That's flipping over this magical line, the x-axis, okay? It's flipped over the x-axis. A reflection in the x-axis. Okay, that's basically it, guys. There's a graph, and we've seen this one before. Do you believe it? Is that the graph of y equals x squared minus 4, Jade? Nod like this. Well done. Yes, it is. Okay. It's the graph of x squared shifted down by 4 units. There it is. Okay. Now, I want to go, what's the graph of the absolute value of that function? What do? Take the negatives, reflect them over the x-axis, and instead of being minus 4, 1, 2, 3, it becomes positive 4. Okay? You could say, where's this point, there and there, but you know what? Graphically, quickly, that's what happens. Okay? This stays like it is because it's positive. This stays like it is because it's positive. The only thing we're doing is taking the negative stuff and reflecting it in the x-axis. Okay? And as a graphing calculator, I've shown you this. Should I show you again, or is that okay? All right, ask me after. Do the observations from 1D also apply in this example? 1D, what's that? Observations. Yes, okay? That's exactly how we did this, right? Yes. Okay, positive stay like they are, negative gets flipped up. Okay? In general, given the function y is f of x, some function, I don't know, x minus 1, x squared minus 4, okay, pi to the power of 12 divided by 6, who knows what function it is. If I take the absolute value of that function, it has these characteristics, okay? We just wrote this. When f of x is positive, okay, the graph of this is identical to the graph of that, right? When it's less than 0, okay, it's a reflection of the graph in the x-axis. We just wrote it, okay? They just said it again. Must be important, right? That's how you do it. That's it. Okay. So, what's the equation of this funky line? We don't care. That's a graph of y is f of x. Okay? Sketch the graph of the absolute value of that. What do? All of this stuff, we leave because it's positive. We take the negative stuff and we flip it over the x-axis. Okay? It's a reflection in the x-axis. That blue line is the graph of f of x absolute valued. Okay? Right? Not too bad. Here's some parabola. Actually, I should ask you the equation of that. You should know. How does that compare to x squared? Right? This thing looks like that. This thing's flipped over already, so that's going to give you this and then it's shifted down by 1 unit, right? That's the graph of this guy, okay? But hey, didn't even ask that. All we got to do is graph the absolute value of it. What do? Everything's negative, so we flip the whole thing. Instead of being -1, it's +1. We're done. Okay? Piece of cake, eh? Okay. Now let's compare these graphs and just talk about domain and range a bit. How does domain change from parts 1 to 3? Okay, let's look at this. What's the domain of this original graph here, the black line? All real numbers. What's the domain of this one? Okay, same thing, right? What's the domain of this guy? That goes on forever, that goes on forever. Same thing, right? Okay, if I take the absolute value of it, does it change? No. Let's look at this one. Did that one change? No, still all real. X goes out forever and ever and ever, either direction, right? Did this one change? Nope. X is all real. X is still all real. Okay, can we come to some kind of conclusion here? Domain, no change. Okay, stays the same. The range, however, does. Okay, all we need to do is just look at this example right here. The range of this function was, well, it's all the y values from here down, right? So before it was everything less than or equal to that point where y is all real. Obviously that's not what that says. Okay? This guy, the range is y is greater than or equal to +1. Okay? So I could write some big, long, complicated sentence telling you the relationship there, but I don't think it's that helpful. Just look at it, okay? All we need to know is the range will change. If you want to memorize that, hey, maybe that'll get you a mark sometime in the future. What happens with the x-intercepts when I take a function and then take the absolute value of it? This guy doesn't have any, so can't really look there. This is an x-intercept. Did it change when I took the absolute value of it? No, it's still there. It doesn't cross it, but if it touches it, remember, that's still considered an x-intercept. Okay, let's look at this guy. I had 2 x-intercepts when I have this. When I took the absolute value of it, did they change? No. Still got those 2 x-intercepts. Okay, how about this one? Didn't change. Okay? Let's come to some conclusion. X-intercepts do not change when you take the absolute value of it. Y-intercepts do. Okay, if the y-intercept was positive, then it doesn't change. But, however, if it was negative, okay, then it becomes positive, right? Because we flipped it up. All right, but visually, just have a look. That's what we've been doing. Right? Okay, this y-intercept was right there. Okay, it was negative. Now it became positive. That's all you got to do. Okay? That's it. Like I said, reciprocal might be a little tricky. So enjoy this while you can. Oh, and we were going to do a little poll, weren't we?